Hello children, today we will be discussing about few properties of water, that is water as a universal solvent. We will also be discussing about water pollution and also the preventive measures. You must have learned about interconversion of states of matter, right? So what is interconversion of states of matter? It is a process by which matter can be converted from one state to the other and back to the original state. Okay, water exists in three physical states, that is in the solid state as ice, in the liquid state as water, and in the vapor state as water, in the gaseous state as water vapor. And we can convert one state of matter to the other state, okay, that is one state of water to the other physical state by either heating or cooling. Okay, so now let us discuss the conversion of solid to liquid. This process of solid to liquid is known as melting. Okay, so how do you bring about the process of melting? Melting is brought about by heating. Okay, so when you heat a solid, it is seen that as the heat energy is being supplied, the temperature will be increasing, and this continues. But at a particular point, the temperature remains constant and the solid begins to change into liquid. Okay, this particular temperature, okay, at which the solid changes into a liquid is known as melting point. And it is seen that at melting point, though heat energy is supplied, okay, though heat energy is supplied, the temperature remains constant. So where is all this heat energy which we are supplying going? Okay, the heat energy which we are supplying, initially it increases the kinetic energy of the particles. But at the melting point, the temperature remains constant. At this temperature, what happens is the heat energy which you are supplying is used to overcome the intermolecular forces of attraction. Okay, now this heat energy which is used to overcome the intermolecular forces of attraction is known as latent heat. Okay, so what is latent heat of fusion? Okay, latent heat is also known as the hidden heat because it's not showing any, though we are supplying the heat energy, it is not showing any increase in the temperature. So latent heat of fusion is defined as, okay, it is defined as the amount of heat energy required to change 1 gram of solid to its liquid state at the melting point without any change in temperature. Okay, so latent heat of fusion of ice can be defined as the amount of energy required to convert 1 gram of ice to its liquid state at its melting point without change in temperature. Now, the latent heat of fusion of ice is 80 calories per gram. Okay, is 80 calories per gram, and this is highest. Okay, the latent heat of fusion of ice is highest. Okay, and this is of very much importance and it has very applications. Okay, for example, like if we need to cool the water bottles or cool drink bottles, what do children? We keep it in ice. So when we keep it in ice, they become cool. Why is it so? Why is it that we are keeping this cool drink bottles only in ice to cool? The reason is the latent heat of fusion of ice is very high, and for every gram of ice to melt, it will withdraw 80 calories of the heat from the contents. So it's going to bring about cooling of the contents of the cool drink bottle or the water bottle. Is that clear? And another application where we come across about latent heat of fusion of ice is, children, like basically after a hailstorm, the temperature drastically drops. This is because hailstorm basically involves precipitation in the form of solid. So the hail is a solid form of precipitation. So what happens when this hail melts? It is going to take out the heat from the atmosphere. So this cools the surrounding. Okay, now coming to the next process, boiling. Okay, so boiling is, children, it is the process of conversion, okay, of a liquid to its vapor state or the gaseous state. Okay, so boiling is the process of converting a liquid into its vapor state, and even boiling is brought about by heating. Okay, when we boil water, okay, by heating, okay, when we heat water, the temperature will increase. The temperature will continuously increase, but at a point, the temperature remains constant. And at this temperature, liquid water begins to change into its vapor state. And this temperature, this heat, okay, is known as, okay, this point at which this takes place is known as the boiling point, and the heat energy is known as latent heat of vaporization. So what is latent heat of vaporization? It is the heat which is stored in the steam, okay? And latent heat of vaporization is defined as the amount of heat, okay? The amount of heat energy or heat required to convert 1 gram of liquid to its vapor state at the boiling point without any change in temperature. Okay, so this is known as latent heat of vaporization, and latent heat of vaporization for steam is the highest, and it is, the value of it is 540 calories per gram. Okay, so the latent heat of vaporization of steam is very, very high, and this is made use, like while we are cooking, it is faster and easier to cook in steam. Okay, so when we make idlis, doklas, when we want to steam the vegetables, we subject this we steam these vegetables, we steam the idlis, we steam the doklas. This is because, children, the latent heat of vaporization of steam is very, very high, and the energy stored in steam is very, very high, and this heat energy can help in cooking the food faster. Okay, yet another example is to drive the steam engines, we use the steam rather than any other gaseous form. This is because, again, the latent heat of vaporization of steam is very, very high, and the amount of energy it is going to transfer is going to be very, very high. Okay, that is 540 calories of energy is transferred by 1 gram of this substance. Is this clear, children? Okay, then coming to what is specific heat capacity. Okay, specific heat capacity is defined as, okay, the amount of heat energy, amount of heat required to raise the temperature of 1 gram of a substance through 1 degree Celsius. Okay, Now, the specific heat capacity of water is very, very high. That is, water has the ability to take in lot amount of heat energy without bringing about a remarkable change in its temperature. The specific heat capacity of water is 1 calorie per gram degree Celsius. Okay, and this is very, very high, children. And what is the application of this high specific heat capacity? Water is used as a coolant to cool the engines in your automobiles. Okay, and water is used in your room coolers. So as the warm air is sucked inside the room coolers, this warm air passes over the mats of the room cooler through which water is going to be sprinkling. Okay, and this warm air is cooled, the heat of the warm air is taken up by the water. Okay, and cool air is given out. Okay, yet another application of high specific heat capacity of water is we use hot water bottles. In cold countries, hot water bottles are placed below the beds. Okay, and water has the ability to take in large amount of heat energy, and this heat energy which is taken up by water is slowly radiated outside, thus keeping the bed warm. So these are the applications, okay, these are the applications of the specific heat capacity. Is that clear, children? Now, what is density, children? Density is defined as mass per unit volume, right? Density is defined as mass per unit volume, and density is inversely proportional to volume for a constant mass, right? So what is going to happen here is, children, as you cool the temperature of water below 4 degrees Celsius, up to 4 degrees Celsius, water is going to contract like any other form of matter. But from 4 degrees Celsius, below 4 degrees Celsius, water instead of contracting will expand. And when water expands, the volume will increase. When the volume increases, the density decreases. That is the reason, children, ice, though it is the solid form of water and solids are supposedly have been having greater density, okay, ice will have less density than water and it will float on water. Okay, it is because of this reason, children, water has maximum density, okay, of 1 gram per centimeter cube at 4 degrees Celsius. So water has maximum density at 4 degrees Celsius. When you cool water below 4 degrees Celsius, the volume is going to increase, so the density is going to decrease. If you heat water above 4 degrees Celsius, again the volume will increase because matter is going to expand and density is going to decrease. So water has maximum density at 4 degrees Celsius, and it is because of this anomalous expansion of water, ice floats on water. This is of great significance, children, because what happens here is, in cold countries, when the temperature falls below 4 degrees Celsius, the water in the water bodies begins to freeze. Okay, so when this happens, when the upper layers of the water freeze and it forms ice, ice being lighter than water will float on water, and this ice forms a layer over water, and below the ice the water remains at 4 degrees Celsius, and that will support aquatic life. So this anomalous behavior of water prevents complete freezing of the water bodies. If this would have happened, children, there wouldn't have been any aquatic life. So this is very, very significant. Another application of anomalous expansion of water would be, children, like, the pipes, the water pipes burst in winters in cold countries. This is again, children, because when water, the temperature outside falls below 4 degrees Celsius, the water inside the pipes is going to expand, because below 4 degrees Celsius, water will expand instead of contracting. So this water will expand, and this expansion of water is going to cause the bursting of the pipes. Okay, so this was about the anomalous expansion of water, children.